Interstate 5 carries about 200,000 cars a day between Portland and Seattle. Imagine a single morning where every single one of those trips just stops. No trains running, no freight moving. Airports coated in a gray grit that completely wrecks jet engines. It wouldn't take a military invasion or a bomb to do this. It just takes a mountain that's been sitting quietly in your rearview mirror the entire time you've lived here. That mountain is Mount Rainier. It's 14,411 feet of ice and rock looming over Tacoma. The U.S. Geological Survey ranks it as one of the most dangerous volcanoes in the country. It doesn't erupt often, but that's not the problem. The real danger comes from what's stacked on top of it, what's rotted away inside it, and the fact that roughly 90,000 people live directly in the path of something this mountain can do without even erupting. Here's what nobody tells you at the postcard viewpoints. The main threat from Rainier isn't actually lava. It isn't even the ash. Though the ash alone could ground half the flights on the West Coast. The real killer has a boring, almost gentle-sounding name, a lahar. It's a massive wall of mud, boulders, shattered trees, and meltwater moving faster than you can drive. It can bury a valley 30 feet deep before the people living there even realize what's happening. Stick with me for a minute, because we need to look at how one bad hour on this mountain could completely cut off the Pacific Northwest from the rest of the country. The people who study this for a living aren't asking if this will happen, they're asking when. Let's look at the ice first. Rainier carries more glacial ice than every other Cascade volcano combined. There's about a cubic mile of it draped across the peak and the sides. That ice makes the mountain beautiful, but it's also a loaded gun, because an icy volcano is essentially a machine for making floods. If you get heat from below, or a collapse from a weak rock face, millions of tons of frozen water turn liquid in minutes. That's the recipe for a lahar. You melt the ice, mix it with loose volcanic rock and old landslide debris, and you get something that looks like wet concrete, but hits like a bulldozer, and it moves fast. On a steep mountain slope, a lahar can hit 45 or 50 miles an hour in the upper valleys. By the time it reaches the flatter towns below it, slows down a bit. But it spreads out incredibly wide and starts carrying whole houses inside the flow. Here is the detail that really gets under your skin. Rainier has done this before. This isn't some ancient geologic history from millions of years ago. Humans were around to see it. About 5,600 years ago, a massive chunk of the mountain's northeast side simply gave way. Geologists call this the Osceola Mudflow. It didn't even need a big eruption to trigger it. The rock had just been chemically rotted out by centuries of acidic volcanic gases, turning solid stone into something like wet clay until it finally let go. That single event sent a lahar racing more than 70 miles. It filled up entire valleys and completely reshaped the land. Today, the towns of Auburn, Kent, Puyallup, and Sumner sit right on top of that exact ground. These are communities packed with schools, warehouses, highways, and families who mostly have no idea their neighborhoods are built on an ancient river of mud from the peak on the horizon. Think about that for a second. The dirt under those subdivisions is the mountain. It already came down once and reached the edge of Puget Sound. The only real debate now is how big the next one will be and how much warning anyone gets. So how much warning are we talking about? This is where the situation gets incredibly tense. If a flank collapse happens on the upper mountain tomorrow, the timeline is brutal. Communities in the Puyallup River Valley might have somewhere between 40 minutes and an hour before the mud arrives. That sounds like a decent amount of time until you picture what an hour looks like in a place like Orting. Orting has a population of around 9,000 people. It sits in a valley squeezed right between the Puyallup and Carbon rivers, which both drain straight off Rainier. On a clear day, the mountain fills the sky right at the end of the street. The town has a geographic trap you can measure with a ruler. There is basically only one main way out. Over bridges and along roads that funnel through tight choke points. If a lahar is coming and 9,000 people all try to drive out at the exact same second, the roads jam instantly. In an hour, an adult in great shape might make it to high ground on foot if they start running the moment the sirens go off. But what about a kid in an elementary school? A person in a wheelchair? Someone who slept through the alarm? This isn't just hypothetical dread. Orting schools actually run lahar evacuation drills. Children in that town practice walking fast toward the hills, the same way kids in California practice dropping under desks for earthquakes. They've done it for years. There's even a footbridge project designed specifically to shave minutes off the escape. When a community starts building infrastructure just to outrun a mountain, you know the threat is real. If we widen the lens, a single valley emptying out is a localized tragedy, but cutting off the Pacific Northwest is a national issue. Look at where the population and the pavement actually sit. The lowlands around Tacoma and South Seattle are laced with the exact valleys that Rainier's lahars follow. The Puyallup Valley, the Green Duwamish Corridor, the Nisqually on the south side. These aren't empty spaces. This is where you find the Port of Tacoma, one of the busiest container ports on the west coast. It's where the warehouses, the rail yards, and the main spine of regional freight traffic run. A major lahar doesn't just bury homes, it buries the logistics network that keeps grocery shelves stocked from Olympia all the way to Bellingham. Picture the Port of Tacoma under several feet of hardening mud. Every container is stuck. The rail lines threading those valleys are snapped or submerged. Highway bridges over the Puyallup are either destroyed or too dangerous to use. Suddenly, the fastest routes for moving goods up and down the coast are choked at the exact point where geography forces everything into a narrow band between the water and the mountains. And the ground game is only half of it. Look up at the sky. If Rainier has a classic eruption, and it will eventually, because it's an active volcano that has erupted many times over the last few thousand years, it will throw ash into the sky. Volcanic ash isn't soft like campfire ash. It's pulverized glass and rock, microscopic and sharp as a razor. It doesn't melt harmlessly in a jet engine. It melts at the extreme temperatures inside the engine and then resolidifies right on the turbine blades, which makes the engines choke and stall. We know this happens. In 1982, a British Airways 747 flew into an ash cloud from a volcano in Indonesia, and all 4 engines quit at 37,000 feet. The crew glided in near silence and barely restarted the engines in time to land. Now drop an ash plume over the Seattle-Tacoma region. SeaTac International Airport handles tens of millions of passengers a year, and Portland International sits right downwind depending on the weather. Ash grounds flights for days, not hours, because you can't fly through it and you can't just sweep it off a runway. The 2010 eruption in Iceland shut down European airspace for about a week and stranded millions of travelers, and that was a relatively modest event. Rainier sits right on top of one of America's most important tech and trade corridors, and it could easily do the same thing. So layer all of this together. Freight arteries are buried, the port is paralyzed, the air corridor is closed, and bridges are gone in the very valleys that connect the 2 biggest metro areas in the region. That is how a mountain that hasn't had a major eruption in recorded history could functionally cut off the Pacific Northwest in a single morning. Let's look at the science for a second, because there's a big distinction here that most people miss. There are 2 ways Rainier can produce a lahar, and only one of them gives us a fair warning. The first way is a standard eruption. Magma rises, the ground swells, earthquakes swarm under the mountain, and gases vent. That process gives scientists days or weeks of buildup. The USGS operates the Cascades Volcano Observatory in Vancouver, Washington, specifically to catch those signs early using seismometers, gas sensors, and GPS stations that measure the mountain flexing by fractions of an inch. If Rainier wakes up this way, we'll see it coming. The second way is the real nightmare scenario, and it's what happened with the Osceola Mudflow. A chunk of the mountain, with its guts rotted soft by hydrothermal acid over centuries, simply collapses without an eruption to announce it. There is no magma push and no warning swarm of quakes. It might just take a heavy rain, a minor tremor, or simply the last straw after the rock has been failing quietly for 100 years, and a face of the mountain the size of a small city detaches and comes down. Because of that threat, the region built a dedicated lahar detection system. Along the Puyallup and Carbon River valleys, there are sensors designed to feel the specific ground vibration a lahar makes as it grinds downhill, along with tripwires and monitoring stations tied into an alert network. The logic is chilling. If the mountain doesn't warn you, the moving mud will. The sensors upstream trigger sirens downstream. buying those precious minutes for Orting and the valleys below. Pierce County runs an outdoor siren system, wireless alerts, and public education campaigns, telling residents exactly which way to run and how high they need to go. It's one of the most serious volcano preparedness efforts in the country. The very fact that it has to exist and that it gets funded and drilled year after year tells you everything you need to know about how real this danger is. But what keeps scientists up at night is that detection isn't the same as prevention, and a warning doesn't guarantee an escape. You can build the best siren network on Earth, but it still comes down to whether a mother can get 3 kids out of an apartment and up a steep hillside in 40 minutes at 6 in the morning in the pouring rain. You can wire every riverbank with sensors, but that doesn't move a jammed highway bridge to safer ground. The mud is going to come down the path it has always taken. We've just filled that path with people. Population is the whole issue here. When the Osceola Mudflow tore through 5,600 years ago, the valleys it filled were just forests and rivers. Today, those same valleys hold around 90,000 residents inside the mapped lahar hazard zones, and hundreds of thousands more live in the wider metro area that depends on the roads, rails, and utilities running through them. Auburn, Kent, Puyallup, Sumner, Orting, Fife, growth in Pierce and King counties push development into flat, cheap valley land. And the only reason that valley land near Rainier is flat is because a volcano flattened it with mud. That's the uncomfortable truth behind the Seattle-Tacoma boom. Some of the most convenient, buildable ground in the region is convenient precisely because it's the drainage path of a hazardous volcano. The homes are affordable, the commutes work, and the warehouses are close to the port. Every one of those advantages exists because the mountain leveled that ground for us with the exact process that could level it again. Think about a quick comparison. We tend to rank volcanoes by how dramatically they blow up. Mount St. Helens in 1980 is the famous one with the lateral blast, the collapsed north face, and 57 people killed. St. Helens is dangerous, but Rainier is scarier for a completely different reason. Its geometry. St. Helens sat in a rural area. Rainier sits right at the top of a watershed that drains straight into one of the fastest growing urban regions in America. It's the same kind of mountain, but it has radically different consequences because of what's downstream, and all that ice makes it worse. St. Helens had glaciers, but Rainier has more ice than any peak in the lower 48 states. That is the fuel. A volcano can produce a massive lahar with a relatively small amount of volcanic activity if there's enough ice to melt and enough loose, rotten rock to carry. Rainier has plenty of both. It doesn't need a spectacular explosion to be catastrophic. It just needs the wrong piece of its flank to let go on the wrong morning. So why does anyone live there at all? Why aren't these valleys completely empty? It's because the last big collapse happened before written history. The mountain has stood there, gorgeous and silent, for generations, and human memory is incredibly short. The economics of a growing city will always push people toward available land. Let's be honest, a threat you can't see and can't schedule feels abstract in a way a mortgage payment does not. People live in the shadow of Rainier for the same reason they live on the San Andreas Fault, or the Gulf Coast, or at the foot of Vesuvius. The danger is real, but rare, while the beauty and the convenience are real every single day. The mountain wins that trade in your mind every morning it doesn't erupt, until the morning it does. Here is how that morning might actually unfold, based on the models. It isn't a movie explosion. It's much quieter and more insidious at first. Say it's spring and the snowpack is heavy. Up on the mountain's weakened flank, after a stretch of warm rain, a mass of altered rock finally fails. There's no giant blast, just a rumble and a collapse. Instantly, that debris mixes with meltwater and loose material. Within minutes, it becomes a lahar, moving 40 miles an hour down the Puyallup drainage. Upstream sensors pick up the vibration, the signal fires, and sirens begin to wail in Orting. In the schools, teachers move fast because they've drilled this. Kids line up and start the walk toward high ground just like they practiced. Some make it, but whether all of them do depends on things no plan can fully control: the time of day, who's home, who's asleep, and how many cars clog the exit routes. Downstream in Sumner and Puyallup, the flow slows down but spreads out, picking up cars, sheds, fuel tanks, and entire structures. folding them into the moving mass. By the time it reaches the lowlands near Tacoma, it's a slow, relentless spread of mud-burying roads, filling underpasses, encasing rail lines, and hardening into something you need heavy machinery to remove. The bridges over the Puyallup that survived are cut off by debris on both banks. The port is jammed, and if an eruption is feeding the whole thing, ash is already drifting towards SeaTac and flights are grounding. All of this happens in a single morning. To be straight about the odds, fear without context doesn't help anyone. A catastrophic event on the scale of the Osceola Mudflow is not a certainty for this decade. These massive flank collapses happen on timescales of hundreds or thousands of years. You could easily live your entire life next to Rainier and never see the mountain do anything but glow pink at sunset. Smaller lahars that don't reach the cities are far more common than the giant ones. The truly massive ones are rare. But rare isn't the same as impossible, and the consequences scale in the opposite direction from the odds. The rarer the event, the more devastating it is when it hits, and the less prepared the public tends to be because it's been so long since the last one. That's the trap with slow cycle hazards. Human attention spans fade much faster than geologic clocks tick. That's why the work being done right now matters. The detection network, the school drills in Orting, the hazard maps showing exactly which streets sit in the path, and the land use debates about whether we should keep building in these zones. This isn't paranoia. It's the same logic as fire drills and seatbelts, cheap insurance against a rare extreme event in a place where the geology has already shown us what it can do. The Osceola Mudflow isn't a guess about the future. It's a receipt from the past. It already happened. The mud already reached the lowlands. The mountain already showed its hand once while humans were around to feel the ground shake. Everything geologists worry about isn't speculation. It's a rerun of an event written right into the dirt these valley towns are built on. We didn't move the towns off the mud. We poured concrete over it, named the streets, and filled the schools. The mountain that made that ground is still standing there, still capped in a cubic mile of ice, and still slowly rotting from the inside where hot gases work on the rock. It's patient, indifferent, and operating on its own schedule. The next time you're driving I-5 south of Seattle and Rainier rises up at the end of the highway, impossibly white against the blue sky, try to see two things at once. Look at the most beautiful mountain in the country, and look at the reason the road you're on could be gone by lunchtime. Both of those things are true, and they've always been true. Most people just never look up long enough to notice. The mountain isn't waiting to attack anyone, and it doesn't want anything. It's just a mountain doing what mountains covered in ice and rotten rock eventually do. The only variable that has changed in 5,600 years is us, how many of us are standing in the path now, and whether we're actually paying attention when the sirens finally start to sing.